So now I want to look at pointers and arrays. And pointers are they are very alike to arrays in several ways. You can work with pointers directly as if you're working with them as arrays. Right, so I'll go ahead and then create an array, and we want to call this array 1, and this square brackets keep the number of elements that we have, and over here is the real elements that we will be putting in there. So I'll just go ahead and put in 4 elements and create a pointer for this particular array. And the normal syntax is int, that's the data type of the variable that you will be pointing to, and then the name of the pointer, and we want to assign the address of whatever variable that you want to it. Right, so this is the syntax. Let's run this, and we hope not to get an error. So cannot convert int to int. So what is the problem over here? So let's just go ahead, clear this ampersand, and we run this, and we have no error over here, right? So I was trying to compare the way of declaring them as with arrays and then the normal way, but the normal way is not acceptable because it threw a compile time error. The normal way is to use the ampersand before the name of the variable, and when we run this, we get an error over here. So we don't have to use the ampersand. You just directly assign the array to the pointer, and it's going to work perfectly. As we can see, there is no error thrown, right? So for arrays, you don't use the ampersand operator, you don't need the address of operator, you just directly assign it. Good. So over here, when we just print out cout, so address of array1, right? So I spelled address wrongly. Good. So what we want to have here is address of array1, and we want to see out p1. We run this, and we have address of array1 is this output over here. Good. So we go ahead, and then I want to print out the first element of this particular array. So what I do is I just use the pointer as if it were an array, right? So we run this, and we get no error. Good. So now what this did was that, so we can see that we have a 1 in here, and that's this one over here. Now, as I have already said earlier, we can use arrays, and we can use pointers directly as arrays. And so over here, when you want to index, you don't need to dereference the pointer over here by using the dereferencing operator, right? So you can just use it directly to get the first element of the array. So this is just p1 and all of that. So I don't want to do that right now. What I want to do is print out p1. So now what I want us to do is to get the address of each of the elements, right? So we have array1, and the first element, right? This is the first element. We want to assign int p2 to be the address of this particular element, and the second one is p3 to be the address of 1, and then the last one is, let's just use 3 of them, p4, and we're saying that it should store the address of the third element in there. So now what's happening over here? P1 is the address of the whole array, p2 is the address of the first element, p3 is the address of the second, and p4 is the address of the third, right? So let's go ahead and then run all of these. So I'll just cout over here p2 tab p3 tab p4. Right, let me just add a new line in there. So now let's run this, and we would be getting the addresses of the first, second, and third elements. We have an error over here, invalid conversion from int to int. Right, so for arrays, when we want to get the memory address of each element, we have to use the ampersand operator before the array. Note, just getting the memory address of the whole array, we don't have to use the ampersand, we don't have to use the address of operator. But if you want to get the memory address of one of the elements, you have to use the ampersand operator. So we run this, and we are getting an output over here right now. So we have the address of array is this, and we have the address of the first element as this. Now what I want you to note over here is the address of the first element is the address of the array, as we have I explained previously in this example. It says that the address of a variable, or yeah, the address of a variable is where the first element starts. So it starts over here and then goes over there. This at the address of the array is the address of the first element, and this is the address of the second. And we can see that 4 units was added, and then to 28 another 4 units over there. So we can see a consecutive stacking, right? So that's pointers and arrays, and that's how to get the memory address of these elements. So how then do we get the elements output on the screen? We looked at that previously when we used the for loop to loop through the array and then printed each of the elements. Over here, since arrays and pointers are most alike, you can just explicitly use the pointer directly without dereferencing it. Right, so we can just say p1 and we want to output the first element in that way with, let's just use a new line. Right, so what we've done over here is we called the pointer and then we put the index of the element that we want in square brackets. So this is going to call out the pointer and print out the first element. So let's run this and we should be getting, I think, yeah, we got a 1 in there. So that's 1 over here for us. So that's how to get the elements using pointers. So we can go ahead and then get the fourth element. We run this, we should be getting, yeah, a 4. Right, and there's a 4 over there, right? Good, so we are done with pointers and arrays, so I'll go ahead and then comment this out. Now the next thing I want to look at is accessing elements of an array using point. I think we've done that already, yeah. So now I want to look at pointers and string literals. Strings are just arrays, but then these are arrays that are made up of character int elements. So for example, the string hello is made up of 5 characters, and it's an array of characters, so it has HELLO. So this is an array made up of characters. When we have this kind of array, string A is equal to, or string A is this and that, so we can say this just works like a normal array, right? This just works like a normal array. It's same as int A, and you have int numbers here. But what we want to talk about is an array like hello explicitly, right? So let's go ahead and then create a pointer and initialize it to the word hello. So we have string p1 and we are assigning hello to it. Mind you, it's an array. It's an array, so we can just do this explicitly without using the ampersand. So then let's run this to see if we will have any error. We run it and we have an error over here. It says cannot convert constant character to string and all of that. So what we should note over here is that the elements of this array are characters, but the elements of this array are strings. So that's why we used the keyword string to declare it. Since the elements here are characters, we have to use the keyword character and not a string, because the characters are not strings. So we go ahead and run this to see if we would have any error. And now we have no error. So just like normal arrays, we can create a, so the point over here is p1, and so we can explicitly print out p1, and what's the, let's print out the third letter, which is going to be index 2. We run this and we should be getting an L, and there we go, an L over there. What do you think if I run this? We have an asterisk and then with p1 plus 1. What do you think? Now let's look at this syntax. We have p1, which is the address of the array, and we are adding 1 to it. What did we say that was? You just shift it to the right. When you shift it to the right, after that you have to dereference it with this, so it actually gets us the element stored at the shifted address. So let's go ahead and run this. So p1 will give us h, address of h, and p1 plus 1 would shift us to e, right? So let's go ahead and shift it by 1 2 3 4 times. So we should be getting the last element. We run this, we should be getting an O over here, right? And this is the O, right? So then this is how to dereference the pointer, shifted pointer kind of, right? So we go ahead and then comment these out as well and move on to the next section. Now what we'll have is pointers to pointers. And when you have pointers to pointers, let's say we have int a and we are storing in 9 over there, and we want to say that int p1 is the pointer of the address of a. So this, we have created a pointer for the variable a, basically the address of a. Now we want to create another pointer to store the address of the first pointer. So we have a pointer which stores the address of the variable a, but then what we want to do is to create another pointer, right, to store the address of the first pointer. So I want to call this pointer p2, and it's going to be equal to the address of p1. Now the only difference is that we use an asterisk for the order that we are. Over here the order it was the first pointer, so we just use one asterisk, but then we are referencing this, we are storing the address of another pointer, so we have to use two asterisks to show its degree. That means this is a pointer pointing to another pointer. If this pointer is pointing to a pointer which was pointing to another pointer, then we have to use three asterisks, but let's just use two asterisks and run it to see if we would have any compile time error. And we have an error over here. It says that invalid type argument of unary that. So what do we have to do? Right, what we have to do is to use the ampersand. I guess you saw it. So we have to run this to see if there will be any more errors, and no errors now. So that means that we are good to go. So the only difference here, as I have said, is the two asterisks. If you're pointing to another pointer, if it were the third pointer, you have to use three asterisks to point to, let's say this is p3, and you're saying this is the address of p2, right? So then let's go ahead and see out p1 tab p2 tab p3. We run this and we are getting three addresses. These are joined over here. So that's how to point to a pointer, right? Now we want to look, the last thing we want to look at is null pointers. And a null pointer is a pointer that basically points to no particular address. We've seen that when we print a pointer, we get a hexadecimal address on the computer memory. But when you initialize a null pointer, so this is a null pointer, let's say p1 is equal to null pointer using the keyword null pointer, or you can just use the keyword 0, not a keyword, but you can just use the value 0, right? So what does this do? What this means is, let's say we have a pointer that we want to pass into a function, but then we don't really have a memory address for it right now. So we can just declare it using a null pointer, and when we print out the address of this particular pointer, it basically returns 0. It doesn't return any hexadecimal address on the computer memory. So basically we have declared it, but then we have not yet assigned any valid address to it. So this is how to kind of declare null pointers and use them before you kind of get a valid address for them. So let's go ahead and then see out the two of them to see if we have any error or any unexpected values. And this is p2, and we'll use the NL over here, right? So we run this and we have 0 0. So basically it's pointing to no particular location on the computer memory. So that's how to declare and initialize null pointers. So that's it for pointers, and I hope this video has really been very helpful. Right, so that was it for this particular video on pointers. See you in the next tutorial.